Welcome to lesson 11.9, Independent and Dependent Events. This lesson is going to focus on probability and how to find the probability when two events occur. So first we need to know the difference between an independent and a dependent event. An independent event is if you have two events, the occurrence of the one event does not affect the probability of the occurrence of the other event. Meaning that if you look down here, you toss a coin and it shows heads. You toss the coin again and it shows tails. Okay? Because the tossing of the coin the first time does not affect the tossing of the coin the second time, that would be considered an independent event. All right? On the other side, if you have two events that are dependent, it means that the one event does affect the probability of the occurrence of the other event. So for example, if you look down here, it says you randomly draw a name from a hat. Then without putting the first name back, you randomly draw a second name. That would be dependent because once you have taken one name out of the hat, the pool of names that you are pulling from is different from the first time because you have one less. So let's look at some examples. There are 15 gumballs in the machine. Determine the probability of choosing each of the three colors and enter your answer in the boxes below. So the probability of getting a red would be 2 out of, we have 2 plus 8 plus 5, so 15 gumballs in all. So that would be my denominator. The probability of getting blue would be 8 out of 15. And the probability of getting green would be 5 out of 15. Okay? These right now are all exclusive, just individual occurrences, or in this case, independent occurrences, because red, I'm just finding the probability of red, then the probability of blue, and then the probability of green. Okay? So I am going to take a gumball out. I got a green gumball. So the first time I got green, it was 15 out of 15, or 5 out of 15, excuse me. Now, the second time, I am one gumball short. So I no longer have 15 gumballs, I have 14. I no longer have 5 green ones, I have 4 green ones. All right, I'm going to express my answer in lowest terms, so I'm going to reduce this answer. So it's going to be 2 out of 7. All right, I'm going to multiply those two together. I'm going to get 10 multiply 15 times 7 for the denominator, and I'm going to get 105. All right, it's going to tell me to express it in lowest terms. So if I divide both by 5, I'm going to get 2 in the numerator and 21 on the denominator because I divided both by 5. All right. So now I'm going to click on the handle to remove another gumball. Oh, I got blue this time. So in this case, it would be the same process. I have blue and then another blue. So I would do 8 over 14. Now I have 7 out of, not 14 anymore, but I have 13. All right. Continue, same process, you would multiply it through. Okay. Not going to bore you anymore. I think you understand the difference between an independent and a dependent event. Just to go over it one more time, let me zoom this in a little bit so it's easier to read. If we are given two examples here, and we're given two events and we want to know whether or not they are independent or dependent. So event A, you roll an odd number and on a number cube. Event B, you roll the number cube again and roll an even number. Okay. In this case, that would be considered independent because rolling the number cube didn't affect the second time. Okay. In this case, in the second example, number 4, it says you choose a member of a baseball team to be the pitcher. You choose a different member of the team to be the catcher. Well, that would be different because we are taking a player, that would be dependent because we're taking a player out to make them pitcher, which means we have less players to choose from for the catcher. All right, so let's look here. We have one problem here. It says you and your friend each purchased a ticket in a raffle in which 30 tickets were sold. The owner of the first ticket drawn wins the grand prize and is removed from the drawing. The owner of the second ticket drawn wins the runner-up prize. What is the probability that you win the grand prize and your friend wins the runner-up prize? So in this case, the probability of you getting the grand prize winner the first time, or in the first drawing, would be 1 out of 30. All right, so let's bring, so I have 1 out of 30. Now, you already won, so there's a, you're taking away a chance, so that would make it 1 out of now 29 that you would win. If we multiply that together, that would get me my answer, which in this case, 1 times 1 is 1. 30 times 29 is 870. So the probability that you win the grand prize and your friend wins the runner-up prize is 1 out of 100, or 1 out of 870. Not very good odds, in my opinion. All right, so come to class with any questions that you may have. Otherwise, that's all I've got for you. Thanks.